This is Module 1, Introduction to Programming, Lesson 2. Now, last lesson we looked at setting up the IDE, an introduction to programming, working with C#, data types and operators. This time I would like to look at classes and constructors. Before I did say that I wanted to look at creating methods and passing values, but I don't think that's appropriate for the second lesson. I'd rather look at classes and constructors with console applications. So what is a class, first of all? Imagine in programming, or maybe in a game, you will have a, let's say, car. Oh, right, okay, so that's a car. I'm going to draw some wheels because it's a car as well. There's some nice wheels on there. Alright, so in programming, we'll look at data types before, so we'll need to think, what does a car have? So a class is a container of things that an object has and things that it does. We call those variables that we looked at last week attributes. So a class has attributes and it has methods. There we go, methods, lovely. A class is a container of all of those things that it has and all of those things that it does. So how does that look in programming? Well, we have 2 seconds, just finding my program. There we go. Okay, so already I've created a new project. How I did that is I right-clicked my solution, I went to add, I went to new project, and then I gave it a name. So I called my lesson 2 because that's what we're doing. It's still a console application, and if I've set it as a startup project, to do that, you right-click the project name and go to set a startup project. Simple enough. So I said before that this is a class, and then this is a method. Let's design what a class would be. I'll tell you what. Yeah. We'll do it for a car. We're going to do this, although some people might argue that I shouldn't be doing this for a first lesson, but we're going to do it this way because I find it easier to manage. Right-click the project and go to add, and then down the bottom we have class. We could go to new item and we can look at the new the list of items, but clicking class will be fine. It's there on the top as well. I want to give this a name of, let's do a, I think cars are easier. So create a car class. It's loaded up and its default settings are as follows. These are the using directories, the frameworks, whatever they're called. This is the location of the folder, and this is the class, this bit here. So let's start off by designing what this car is. So in object-oriented programming, we think about objects in games, or classes in games as objects. So if I think of a car in a game, I think to myself, what does a car have? Yes, a car literally has wheels. But maybe in our very simple game, it doesn't need to know how many wheels the car has. A car might have a speed value. It might have a, let's think, what else does a car have? It has speed. Yes, it has acceleration, but we're trying to make this nice and simple. So let's go with, actually, let's not have an integer. Let's have a string for the make of the car. Let's have a string for the make of the car. It's a little less, should look like that. So there's a string called make. That's fine. So that'll start us off nice and simple. What we should be doing is having, we use this as a blueprint to create lots and lots of different cars. So we should have a car object and be able to stem off different types of cars with different names. That is very simple object-oriented programming, so that's how that looks. So, if I were to create a new instance of this, which would look like this, okay, so new instances is like creating an object from this class. To do this, you type in the class, similar to typing in a variable. I'm going to call this one, let's do Audi, why not? How that looks to something else, an integer is also constructed the same way, but we're creating an instance of the car object. Here we're creating an instance of the integer object. Okay. Some syntax with these classes is we need to initialize these by saying it is a new car. So car, which is the class name, Audi, which is the object name, equals new car. Okay, so I'm going to reference that as the class and that as the object. So please bear that in mind as I'm talking through this. Class, object, object, class, object, class. Okay. So with that now initialized, I could also create a second one. Exactly the same. So it looks a little bit like that. I don't want to delve into too much about what you are. For now, just imagine that this is an Audi and it has no. We haven't set what the. We haven't actually set the speed or the make yet, and that's okay. That's what we want to do. So how do we set the speed and the make for each of these? Okay, so really I could just go 12 and then I could go Audi. If I did that though, just a couple of mistakes, tidying that up. If I did that, it would mean that this Audi is called, or its make is Audi and its speed is 12. And this object called Nissan will also be Audi and 12. But every time that we want to create a new one, we want to construct those values. So, what is a constructor? I'll start out by typing what it should look like. Public car. That is the name of the class. Has to be identical. And then we put these two brackets in. And then we put two curly brackets in, like so. I'm going to call them curly brackets because I always forget the names of these. The actual name of the brackets, always forget them. So these are brackets, these are curly brackets, like fries and curly fries. So these two brackets here represent this section. They are both empty, but we want to be able to customize what those values go into. Let's type in int spd and string make. Okay, I've done them specifically like this for a reason. I'm going to tell you that in just a second. Let's go to my program, and now look, there's an error on this object, and it's saying that there is no argument given that corresponds to the required formal parameter spud of car.cast in string. So in other words, it's saying there's some values missing here. It's asking for that int spud that we created and string make. Let's have a look. Int spud, string make. There they are. Just for sake, I'm going to clear these. It wouldn't make any difference, honestly, but just bear with us. So, let's now add a integer for speed. I'll put this as 200, and we need a string. Audi. And again 150, and it's make Nissan. Okay, so that allows us to construct and initialize different objects of the same class, but give them different values. How would that be important in games? Let's delete this and start again. Let's get rid of all of these. So why is that important in games? Well, imagine you design an enemy class. So I'm just quickly writing enemy. So imagine you design an enemy class, and an enemy class has HP. But that's a terrible way of writing HP. But what we want is to use the same code, but save time by creating different versions of the same enemy. One enemy might have 100 HP. Another enemy might have 10. Another one might have 1,000. So we're creating different versions of this class so that we can give them all different values. Let's go back into the program and hit start. Okay, so it's going to flash, it's going to run, but it's going to close itself. Let's do some Console.WriteLine stuff, but we've got to do a few steps first. So this is kind of one of those pay attention as I go kind of parts now. So it says here car.speed is never used and car.make is never used. So this value and this value is empty, it's not being used. In programming, we have this value and we need to save it somewhere. So it's fine just typing it in, but where does it go? We can't just save it into here because we want to use it and play around with it. We can do this. Speed equals spud. What happens there is it will take this number 200 it'll take that number 200 and it'll pass it from here into here into here and keep it safe up there. And we need to do the same with Audi, or the string that is there, and we're going to put that into this one. So let's type in make equals make. Hang on, there's actually a bit of a problem here, isn't there? Because I've got two things with exactly the same name. I have that saying that whatever you save into there goes there and then back into there. But that's not going to work. It's saying here that it actually says assignment made to the same variable. Did you mean to do something else? Yes, I did mean to do something else. So could either change the name of that, which is not a good thing to do, although it does work. You don't have to do that. You could also say this dot. So this references car, this car class. So this versions of make is equal to, oh well, not is equal to, contains or is the same value of make. Okay, so that's passing into there. Now we've gone to the program and that should be fine. I'm going to run the program and it's not going to do anything because I haven't told it to do anything in the main method. It's just create an instance of the class. Thanks for opening that presentation there for us. So this time I'm going to add just a couple of lines of code, same as we did before, which is Console.WriteLine. That'll just make the program stay on. But again, it's not doing anything yet. I'm just not doing anything yet. Let's try Console.WriteLine and let's write out Audi. We're getting the Audi thing dot, and let's run toString and see what that does. Hit start. And this, so what's happened here excuse me, is it's seeing the Audi object is from the car class inside the lesson 2 program. Using .toString can be used to determine what data type it is or what size it is, etc. I'm going to quickly add an integer into there and then just run it and just see what it says this time. There is an error. Why is there an error? Unused equals 12. Can I do that? Will it let us do that? Yes. Oh, it's just run 12. That's not what I wanted to. That's actually converted into a string. Yeah, so it converted that Audi into a string, and that's how it looks if it was a string. It converted A into a string, and what its value is 12, and that converted that into a string. What I would like to do is print out what the speed is and the make is of the car. Now I would like to just go Audi dot and pull out some of those variables. We can't just do that unless we make them public. Public is an access modifier, and it allows us to determine whether this object called speed, or this attribute called speed, can be read by other classes. So I press start and speed has now appeared. What hasn't appeared is the make, because that is actually default as private, so we can't see that. So let's run that and see what it says. Dot speed, and it is getting that value. Let's hit start and see what happens. There you go, it says 200. The speed is 200. We could even add a few things. So let's just add speed is and then you type the speed, and the model is, get there in the end, the model is and Audi dot. Oh, we can't use make, can we? What do we need to do to make to access make? I could just type it in. What's it saying? It says inaccessible due to its protection level. If you hear something like that, you'll probably need to do something with the access modifier. Looks like that. We have public string make done. Right, let's see how that looks. Let's run the program, and it should say speed is 200. The model is Audi. There we go. Alright, let's do exactly the same underneath for Nissan. Let's go and change that. Please, if you would type this out, if you type it as you go, please type out the entire line. It is good for you to do that, so you just get used to the different things. Okay, there we go. So it's printing out different values for the same class. Okay, so the reason why we do that, like I said, is creating different instances of the same class. We've demonstrated that now. Let's quickly run down what we've done so far, as we have already covered 20 minutes. I don't really want to spend much more time on this. So we have the car class. It is a blueprint, let's say, that we can use from different objects. Here we see what the car has, and this is what is called a constructor, and we use that to construct objects of the same class. We can say that this car is going to have speed, and we're going to type in the make, but we need to save them somewhere, and we save them by passing in that across into there, and then back up into there, and it gets saved there. If you want to follow how the program runs, if you use, where is it? I think it's under debug and step into F11, you can cycle through how the program works one step at a time. Once it runs, so it creates a new instance of the car, saves them into those two values, just like that, closes that off, and then creates an instance of the car. prints, saves those two values over, then runs out Console.WriteLine, Console.WriteLine, then runs Console.WriteLine, and we end up at that point. And that is essentially classes and constructors. What if we wanted to add more once we're already finished? Let's see what happens. What else does a car have? Car also has, I'll tell you what, let's be boring and do wheels, because it's nice and easy. Int wheels, so it has wheels. What's the problem here? It's already breaking. It needs the value of wheels. 4 wheels and 3 wheels. Why not? It's a 3-wheeler Nissan. Back into the car class. So that's being passed into there, but it needs somewhere to go. So let's see if it's somewhere. We need to create a public. I tell you what. Watch what I'm doing, and I'm going to do a mistake, and I'm going to do it on purpose. This dot wheels equals wheels. That's fine. And then it has a problem. Does it have a problem? Will it have a problem? It doesn't have a problem. Okay, that's strange. Let's try putting an integer inside a string. There you go. That's what I was after. An issue here, a problem. It's saying you can't convert int into string. You can convert an int into a float. Remember what we talked about with float before, but you can't convert a float into an integer. Can't do that because it might be a half number. There you go. Right, so put that back the way it was. Your task is, following this, you need to create a class. I'm going to write this down for you. Create a class. Create a class for a component in a game. It could be an enemy / player or whatever. It must pass 4 variables and create 3 instances of the class. So you might have player 1, player 2, player 3 might have different health, and let's also add Console.WriteLine all of the values. Simple enough. Okay, so there is your challenge. That's what you need to do. Enjoy. Once now that we have that out of the way, we can move on to the next step, which is now we can finally look at things that classes do. Passing values and creating methods. That should be a nice and simple task. Thanks for watching. And yes, next time we'll do methods. Next time we'll do that. But rather than doing a new project, we're going to just add to the end of this class.